Alright, hello everyone, and we're back here. So let's take a look at another example like this here, just to set things up. So we're given information here about a bunch of angles. You can see in this situation here. So we have what appears to be angle 2 measuring 27 degrees less than 8 times the measure of angle 1 here. And we have 43, and 43 has a measure that's 46 minus the measure of angle 1. Compute the numerical value of angle 3. Okay, I mean, that seems pretty fair here. We note that in this situation, for some reason, something like this here, all of these are expressed in terms of angle 1. So it's a good idea for us to go ahead and write that out. So let's let angle 1 be x, so I can put that in here. Angle 2, as you can see in this situation, is 27 less than 8 times the measure of angle 1. So that means this means x is 8x minus 27. And angle 3 here is 46 minus angle 1. Okay, great. So it's 46 minus x. So we can very easily go ahead and set this up here. Note that in this situation, something like this here, right? We see that we have a straight line. We're told that B is a straight line here. So that means these two angles are a linear pair, therefore they're supplementary. So I can write out 8x minus 27 plus x is 180 here. And that tells us 9x minus 27 is 180. So that means that 9x, I believe, is 207 here. And then we can divide by 9 here. And we get x equals 23, if I'm not mistaken, right? Because this is 180 divided by 9 is 20, and then we have 27 left over divided by 9 is 3, so you have 23 here. So we can go ahead and fill this in. So we know the measure of angle 1 is 23 here. The measure of angle 2, just to be on the safe side, is 8 times 23 minus 27 here. And hopefully that should work out, right? That's 160 plus 24 is 184 minus 27. 184, 164, 157 here, which makes a lot of sense considering that this should be supplementary to that. And the measure of angle 3 here is going to be 46 minus 23 here, which is 23. Great. Now, note that this is a great solution here. But some of you may propose an alternate solution. Some of you may propose, wait a minute. We know angle 1 and angle 3, right? So we can go ahead and set this up here. You have 46 minus x equals x. So that implies here that 46 equals 2x, so 23 is equal to x. And that transposes into this solution up here. Now, before we move on for this, I'd like you to think about this for a bit. What's going on with this solution? I mean, this seems perfectly valid here. But of course, considering this, you made a bit of an assumption here, right? If you look back at the picture, if you look back at the information you've given here, we're making the assumption here that these two angles here happen to be congruent because A and B happen to be parallel, right? I mean, instinctively, that's probably what you did there, and, that's okay. Go ahead and admit it. There's nothing wrong with that. But notice again, note the information here. There is nothing here that says that the lines are parallel to each other, right? There's nothing here that has that. For all we know, these two are just, these look parallel, but they could be very, very slightly off. I can have line A be very, very tilted very slightly so that if I were to extend these lines to the right, for 10,000 miles, they'll eventually meet. So note that we were not told that the lines are parallel, but in this situation here, it seems like they should be because of the fact that we end up with these congruent angles here. So what we have here, ladies and gentlemen, is a way that we can think about the theorems in reverse, right? Considering what we had here, you might recall these theorems here, right? You remember these from our we've been using these theorems throughout the last several lessons here. We see that two parallel lines are cut by transverse and the alternate interior angles are congruent. So is it sufficient for us to go backwards? Can we go backwards here? Is it possible that if we have alternate interior angles congruent, then the line should be parallel? Is that possible here? So it turns out the answer to that is actually a very resounding yes. And we can create theorems here that happen to be sort of the opposite. Well, not necessarily the opposite here, but we can see that they're the converses of all the theorems that we had before. So now we can mention something like this here. We can say that two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Notice now that we're taking the converses of the theorems. If you may recall when we studied Boolean logic here, right? If you have a conditional statement, the converse may not necessarily be true. This is an example in geometry here where you have a theorem where both the theorem and its converse happens to be true here. So in theory, we could combine this together to create a single biconditional statement. But I'm actually going to keep these as separate conditional statements because each has its own specific purpose here. Notice that each of these will allow you to, each of these you start off with congruent angles and then you conclude that the lines are parallel. Whereas when we had before, this like here, these you started off with parallel lines and you were able to conclude congruent angles here. So you'll note that each of these theorems has a, each of the theorems that we had in the previous lessons here has a counterpart, its converse here, right? We have one with alternate interior angles, we have one with alternate exterior angles, we have one corresponding angles. And yes, you can actually keep going here, and right, we had a theorem that involved interior angles on the same side of the transversal being supplementary. You can do the same thing here. So you can say if two lines are cut by a transversal, so the interior angles on the same side of the transversal are supplementary, then the lines are parallel. That's also fine too. Now, I mentioned before that the theorems, the initial four theorems, are sort of interrelated with each other. We would have to prove them by simply assuming one of them is true and then showing the others are true here, right? So if we go back to this here, right, if you may recall, right, if we go back to this, we would have to assume that one of these is true here. So for instance, we assume that this first one is true here, and we can show that through some manipulation that the other three have to be true here, okay? And as an exercise, you can try to do this on your own. Pick one of these theorems to start, assume that that's true, and then prove the other three based on it here. Just like how it works in this structure here, it works in this structure as well. We can take any one of these theorems here. So, for instance, I can take the fact that the alternate interior, the parallelism creates alternate interior angles that are congruent. I can take that as a fact, and then show that the other two have to be true based on that fact here. So, much like the same sort of construction that occurs with the basic theorems that we looked at over the past 2 or 3 sessions, the same sort of construction occurs here. And that's no accident, considering the fact that these theorems are just merely converses of each other here. So it should work out pretty well.